Hi everybody, and welcome to this Integr8tor 2024.06 release video. My name is Dirk Leroy, I am with UCAMCO in Ghent, and I'm pleased to be your host today on this guided tour around the new version of your favorite quotation and engineering data analysis tool. This June release is in fact the first of two Integr8tor releases we have planned for this year, or I should rather say two versions of Integr8tor and UCAM we have planned for this year, because as you know, we do these releases together. Integr8tor and UCAM always come out on the same period. So this June release is the first of two. The second one currently being scheduled to come out around November, December time this year. So that will become a .11 or a .12 then. And you're right, it's not terribly long since I announced our previous release, but as you will see, we have already quite a list of additions and extensions again to help you shape your sharpest quotations and assist you in engineering your products the way they should. So let's just dive into it and see what this version has to offer. As always, I'm using a presentation to take us through. And on this first slide here, I just want to give you an overview of some of the highlights that are there. There is an item on barrel surfaces per tool via Empat, something that has come up in earlier releases and is back again with some more refinement. Exposed copper to board surface ratio is an item that I will talk about, pad-to-pad clearance based on layer netlist. Or in fact, it's a bit broader than this. It's basically copper-to-copper clearance, but pad-to-pad is probably the more important item in there. A topic on legend to solder mask defined pads. I will briefly talk about. There is something about checkpoints and the units that we use in there. An archive contents exclusion option. Configurable step names for ODB++ export. And in fact, there is probably just about the same amount of other features and items in there, which I will basically just briefly touch upon towards the end and refer to the technical release notes where you will find all details on any of these items. So the first one we want to have a look at is this individual barrel surface areas per tool. You will recognize the table in front of you. It's the drill tools as it appears on the QED PDF format. And as you will see on the right-hand side, we have added a wall area or barrel surface. Sorry, is the same thing. And it lists the surface of all the barrels per tool. So if we would look at this first line here, the one circled in blue, this is about a blind program from layer 1 to layer 2. It has 150 micron as the tool diameter and a total number of holes in the PCB of 32,801. This yields for this particular tool a wall area, so the sum of all these barrel surfaces of all these 32,801 holes gives you a square surface, in this case square decimeter, of 0.1649 in my case. And that is something that we do, as you can see, for each tool that is drilled. In case there are slots or so, that is something that we leave out. Now, the background for this is that if at some point holes need to be plugged, resin plugged or copper plugged or whatever, this detailed information gives you a handy aid to adjust the copper surface of the job at that point, because at that point, the barrels that will be plugged will no longer be exposed to the plating process. So therefore, it basically refines, or it gives you a more fine-tuned control of your copper area for the job, and therefore it should also give you better results and better control on the plating process. That is part of the drill tools table. As said, it comes just with the QED analysis function. So there is nothing special to be done, nothing special to be set up. There is nothing in terms of licenses that's all taken care of. The second one is the VIA in PAD, the paste layer analysis. I think in the previous version, or maybe the one before, we already had a split up of VIA in PAD between PTH, so through holes, and blind. Now this whole thing with VIA and PAD, or the VIPO as it is sometimes called, the VIA and PAD plated over, is a rather complicated and also expensive process. And sometimes designers, the end users, are not always aware of the consequences and more particularly the extra manufacturing costs that this may bring about. So typically what we see is that designs that have this VIA in PAD feature, they will go through some sort of loop from discussion and review with the customer. Sometimes it can easily be avoided and that would make it a cheaper product, that sort of thing. Now, from the fabricator point of view, there is fabricators who will say, yes, VIA and PAD is okay, but okay, if it's sitting in an SMD pad, that's important. But for instance, heatsink pads, I do not care. They can be in there, but it would not be of interest, certainly not at the time of quotation. And then yet again, another group of people will say, yes, that's all very well, but we are basically only interested to go in this loop of discussion with the end customer in case we see that there is holes, fire holes that touch the paste layer in a job. The paste layer, which basically indicates there where the component, the surface mount component, is going to sit. So as I said, it's quite a sophisticated topic and a lot of views on it. And to satisfy this latter category of people, so to be sure that the discussion only takes place in case the via holes are going through the paste layer data, this version of Integr8tor comes with an extended summary. So it's sitting in the header where basically next to the VIA and PAD, the standard one that we were reporting before, we now also report the holes when they go through, or if there are instances where via holes go through data on the paste layer. And just like with the normal VIA in PAD, you see that the holes in the paste layer, they are split up between through holes, the top to bottom ones, and on the other hand, the ones for blind. That too is something that will be filled out automatically, provided, of course, that your job contains paste layers. That is a prerequisite, obviously. But other than that, again, this is something which comes as part of your maintenance contract. It's covered by the auto analyzer licenses, which most of you probably have. Third item I want to expand a little bit upon is the exposed copper to board surface ratio. We all know that the exposed copper, so that is the copper that is free of solder mask, the copper that you basically see after the solder mask has been applied. That surface is, of course, the one where the surface finish is going to deposit, and therefore, depending on the type of surface finish to be applied, the area basically represents an important factor in calculating the cost in that the more exposed area that you have, the more exposed copper that you have, the more area that is going to take surface finish. And if your surface finish happens to be gold, for instance, that is quite an important thing. Now, a number of fabricators had mentioned that basically as a crude measure or as a rule of thumb, you could say what they do is they look at this area of exposed copper and they would like to relate it to the total board surface. So you think of the outline of a board that has a certain square decimeter, whatever. And then the exposed copper is also a surface, so the same square decimeter value. What they say is, okay, if you relate these two together as a ratio or as a percentage, if you would, then what those group of people, those fabricators will do is that once this percentage achieves or crosses a certain limit that they have in their potion themselves for price calculation, once this percentage gets high or crosses this threshold, what they will do is they will have to call for additional manufacturing charges. So that would have an impact on their quotation for that particular product. So that's an item that you will find in the copper areas section. Most of you probably know. And just like the other ones so far, this does not require anything special, no setup, no extra license. This is basically, sorry, again, just part of the upgrade. Our next one in the list is the pad-to-pad clearance based on layer netlist. Now that maybe requires a word of explanation. It has always been the case traditionally that Integrator calculates copper-to-copper clearances based on a job netlist. So at the time that we do this, we have the full job, we have all the drill holes, plated, non-plated, all copper layers. And we have always used the layer netlist the job netlist, correction, the job netlist to do this copper-to-copper clearance calculation. Now, what that means is that if you look inside one layer and you would have, let's take the example of two pads, if you would have two pads sitting relatively close together, and the distance between the two would happen to represent a minimum. So it would be the smallest clearance distance on that layer between any two pads. Up until now, we would not report this because they belong to the same net. We have another item, a different item, which is called same net spacing, where we deal with spacings between items of the same net. So we wouldn't report this. Now with this extension that we introduce in this version, we will also consider for the copper-to-copper clearances, we will consider the layer netlist. And what that would mean in basically the same case as I was just describing, it would mean that from now on, if these two pads are not connected inside the same layer, but via some drill holes somewhere else, if they are not connected on the same layer, they would now get reported in case they represent a minimum, of course. If they are 200 microns apart and there is other copper to copper, which is 150 microns, of course, they would not show up. But if they represent the minimum, that would now actually become visible in the overview in the QED report. The QED report, which for this purpose has been extended with an extra section. As you can see, the copper layers copper-to-copper clearance is something that you probably know from earlier versions, but there is now an extra table, an extra section that can be added where all of these same analysis results will be listed, but based on the netlist inside one layer rather than inside the job. This would be a screenshot of one such case. The zoom up here from the bottom left is actually these two pads, and as you can see, inside the layer, they are not connected, but if you bring up one of the plated drill files, and we go to this last but one inner layer, you would see that via the two drill holes, these two pads are connected on there, so they do belong to the same net. So in previous version, those would not be reported as minimum pad to pad clearance, again, assuming that this distance here is the minimum inside the layer. We would have gone through the next one higher up where the two pads belong to a different one. But as we said, from this version onwards, you now have the ability to visualize like before, the job netlist based, or with the new one, the layer netlist based. And the way to do this is actually very simple. It has been made available as a separate section in the preferences. So if you go to your setup of your QED report, you should find an item which is called copper layer details by layer netlist. You drag it from the invisible section into the visible columns, and from the next jobs onwards, it should appear on your QEDs. If you're interested in only those ones, just get rid of the previous one. This is the one based on job netlist, and then you will only have the one for your layer netlist. Okay. Right, at this point, maybe a quick look. If I go to my Integr8tor cockpit, I have here this job, which very briefly, we can just illustrate where you will find these things, the ones that we have explained so far. So in the summary section below the images, well, in my case, depends on your setup, how you have arranged your blocks, of course. But in the summary section, you will find the ones with the paste analysis, where we are looking to find fireholes that touch the data in the paste layers. If I bring up my bookmarks, something else that we talked about was not this one. Sorry, where do I want to go? Where do I want to go? There was something with the copper areas, yeah, where we said that you will find these percentages for only for the section solder mask as applied, where we will have done the calculation of this surface value compared to the complete board surface value. There was a item on the drill tools where we have the wall area, so the barrel of the individual drill holes, where you can see, for instance, here is a case where there are a number of slots, so the routes in the PCB, for which we have made abstraction of this. So we had the barrels, we had the via end pads, we have the exposed copper, and then we should have the last one, which is the Oh, that's probably not on this job, but on the on one of the others. Oh no, here it is. Sorry. The copper layers, copper to copper analysis, where if you would look, I think if we are lucky, we can just fit this on one screen. So this would be the one that we have historically always had, the copper layers based on the job netlist, the copper layers, copper to copper clearance by layer netlist. And you will see indeed that, for instance, pad to pad here, if you take the netlist confined only to one layer, that you will come out with lower pad to pad values, or pad to trace 13 versus 60 or 6 versus 75. So as I said, it's there to be used or not to be used depending on your needs. So feel free to add the box to the QED or not do so in case you think that this is of no concern to you. Back to the presentation, the clearance legend to solder mask defined pads is something in the legend section. The legend section, which is also part of the QED traditionally for a long time, but you will see that what has happened, there's been a split up in the distance between legend data towards copper. So typically your outer layers, because that's where your legend might encroach on. So Up until now, we were basically always considering the paths on the outer layer as being copper defined. Copper defined paths are paths which are, as the word says, they are defined by the surface of the copper, compared to solder mask defined paths, where you have a certain size pad in the copper, and then the solder mask on top of it is somehow smaller. So what you see as the exposed surface through the solder mask is actually smaller than the actual copper pad itself. So this has been represented here in this section. So this is legend distance to copper defined pads. And inside these copper defined pads, which we already did, make a distinction between component pads that can be solder mask defined, although exceptional, but they do exist. SMD pads that may be copper defined. Sorry, I was confused a minute ago. So this is the copper defined pads, of course, simple component pad, SMD pads, BGA pad. And then you have the variance of these three pad types, where the solder mask is somehow or somewhat smaller than the actual copper surface itself, again for component, for SMD, and for BGA. As well as for via pads, but because it's not uncommon to have via pads partly covered with solder mask, we have kept them out in a separate column, not to counterfeit any minima that you would see here, and that you don't want to be obscured by the fact that there is via pads which are partly covered with solder mask. I think if all goes well, I have here in checkpoint. Is that the one I was? Yes. So this would be a case like this. Let me also switch on the mask. Right, green is the legend layer, red is the copper, obviously, the drill, and there's the blue part. The blue part is the solder mask, which translates here into magenta. And if we zoom in a little bit, so from this version onwards, if you if you are interested in this particular value, you will now have the value between edge of your legend and solder mask SMD defined pad. In this case, it would be a solder mask defined SMD. Okay. Same story as before in terms of, where is my PowerPoint? There it is. In terms of licenses or setup, nothing to be done. This is basically, again, part of the auto analyzer license. That is, again, part of the upgrade. The checkpoint unit conversion is actually a nice one. Since a couple of years now, we have the choice of unit that is available in the checkpoint, but a number of these values that we were displaying here were suboptimal in displaying, let's say, if you changed from one unit to another. And the background is actually quite nice, because the world has become one big office. Many fabricators today have locations or facilities all around the world, but at the same time, sometimes they have one central integrator server somewhere. So assume that this integrator server sits in Europe, then people would have a tendency to run in metric. But if one of the offices which is connected to this server is in, let's say, the US, there people would like to know and to read and to understand in mil and inches maybe. And up until now, this was done for a number of values in checkpoint, but we have streamlined this in this particular version, so that now whenever you change unit from A to B, all relevant parts of the checkpoint interface will respond the way you want them to show. Okay. Archive contents exclusion is the next one on my list, and that's about the following item. Sometimes in a zip file, there is much more than just the image that you want to analyze or that you need to analyze. In the zip file, there are very often, and it's actually more rule than exception, but there is very often multiple directories, and the contents of these different directories can vary enormously. Sometimes you have a directory with the PCB and it's in format Gerber, and next to it is another directory and it's in format ODB. It's basically the same product and the same thing, everything, it's just two different formats. Now, we have handled this historically quite well, but there is other cases where, for instance, these directories, 2 or 3 directories, sometimes there will be one called Gerber and the second one will be called drill. So in that case, you still want to grab these two. The data which is in these two directories need to come together to make up one PCB, because you need your coppers and you need your drill. But in yet another case, you sometimes have the data for CAM, and then a subset of this is in a second directory than for assembly. And then it becomes sometimes very confusing because layers are double. They exist in the CAM directory, but they also exist, some of these layers or a limited number of these layers exist in the assembly directory. And there you don't want everything to get mixed together because your end product is not really reflecting what the PCB is. And then yet in another case, there might be a directory where you have people have put in all sorts of documents or readmes and that sort of information. So really anything goes in terms of incoming zips and archives. And although I think we do a pretty good job in picking up the right one and combining the right ones, we have introduced a new version, which is typically a use case for a situation or a fabricator where the incoming archive does not go straight away to Integr8tor for analysis, but it's sort of pre-scanned. What you can do now is if somebody opens the zip beforehand, inside the zip, you can actually create a folder yourself, give it a particular name, and whatever you put in there, you can actually keep it away from the Integr8tor analysis, in the sense that inside the Integr8tor configuration, you can from now on, you have the ability to specify a preference in which you can say discard input folders. And the value of this is a list of folder names, one or several as you wish. And what it actually does is it says during input, it tells Integr8tor simply to disregard any information which is, in my case here, ref, doc, or panel. So that would mean that, as I said, if the archive is pre-scanned and somebody would put the single image data together or in the root of the zip, it doesn't matter, and then put all the rest inside one of these directories which you create yourself, then Integr8tor would just be looking at the data that you want Integr8tor to look at without being tempted to try and pick up information from any of the other folders. Now, in some cases, what that will do is it will give a much higher hit rate on first pass success, because your stack up is much more likely to get correct if only the information is available for the PCB that needs to be examined. So that's rather nice if you are in this situation where the incoming data is first going through some sort of pre-scan before you submit it to your Integr8tor. Question about setup or license for the previous one. Sorry, let me go one back. Indeed, this is a user preference that goes in the job work profiler node. But other than that, there is no extra, there is nothing involved with licensing or anything whatsoever. So it's just a matter of setting up the folder names that you want Integr8tor to disregard. That is not the same for this last one on my list here, the configurable step names for ODB++ export. in the sense that, first of all, what do we do? Sometimes to communicate with your customer, or if data has to go to CAM after Integr8tor, people would like the data inside an ODB++ file, the step names there, or the step name there, to be named in a certain convention. If it's about the original customer data, some people might prefer the step name in ODB to be ORIG, or if it's data that has been somehow changed or modified, the step name may be added and whatnot. Yeah, so this is the sort of this is the situation that we are in. And up until now, we basically had fixed names for these steps when we made output. But again, in order to facilitate communication, CAM customers or different offices from the same fabricator from one to the other, it's sometimes helpful that these steps can be easily identified by their name. So that is why there are basically 3 different job versions that you can get out of Integr8tor. One is the original job. There is one called the rebuild job, and there is a clean job. And for each of these 3, you have now the ability to define the step name in the ODB output for that particular set of data. Yeah. Now, although this feature by itself, the step names, is not linked to any license, what you see here, the original job output, the rebuild job creation, and the clean job creation, that in itself, those are 3 licensed items. Plus, on top of that, the ODB export is also a licensed feature. So before you can make use of this feature, you need to have at least one of these 3, plus then the ability to do an ODB output. So that's a little bit different than the other ones that we had so far. Right, I think that brings us to the end of more or less the detailed items that I wanted to go through. This is a number of other items which you will find also available in the release. The first one is configurable step names for DPMX import. DPMX import, a little bit like ODB, it can have step and step names. We have now also implemented a system by which you can say if I receive an DPMX or IPC 2581, by the way, that's the same. When I receive this data and it has multiple steps in it, which is the step that I would like to read in. It's a system which is very similar to the ODB way of working that we have for inputting the data. There is something for reusing the incoming ODB path type information. As you may know, ODB objects, flashes, can have a limited number of path designations. So there is information, or there can be information in the ODB which says this is an SMD path. Up until now, we were not taking this into account when reporting the number of SMDs and so on. From this version, we will do this. This happens behind the scenes. There is basically nothing to set up or to do. It's just that if this information is available, we will make use of it for the reporting. There is something changed in QED XML for the copper accuracy in imperial units. We used to write square mils there, which was a very weird one. Now this has changed to square inches so that it more or less reflects with what is on the QED PDF. The assembly panel graphical representation is something, it's a minor thing where we have streamlined it with what you see and do in the panel sizes editor. There is better support for archives which have no real data inside, but just a PDF or something else. Enhanced support in terms of the if you want to communicate with your integrator via scripting, via programming. So this is really an item for people who are into automation. As I said, this is all explained in more detail in the release notes. So make sure if you see any of these items here which take your interest, make sure that once the release mail is there, to go and check out these things. Shadow outlines is also something. Shadow outlines in the rebuild job. Shadow outline is basically a sort of copy of your outline, but it's a copy of the board's outline, but sitting in the copper layers. Yeah, there's a number of optimizations that we have done there as well. Again, you will find it explained in the release notes. Layer exclusion from painted data. In some cases, it might be an idea not to go and optimize painted silk layers or mask layers to facilitate linking with legacy systems, for instance, is one case that has come up. So there too is something that an item that has been optimized or implemented. Click charge support for integrator servers on air-gapped networks. That is the case where click charge, first of all, is the system in which it's a sort of pay-per-use system for integrator customers if they choose to go this way. And the prerequisite for pay-per-use or for click charge would be that your integrator server can reach the internet, and in secure facilities, this is not always a given. So there is a new license by which we can collect the click charge, so the usage locally on the machine, and that you then send it manually via another system which is connected to the outside world. Data processing speedups and first pass hit rate enhancements are two evergreens. There too you will find a number of examples and cases in the release notes of what we have been doing in terms of better recognition of metadata, for instance, drill tool lists and that sort of thing, for better or for higher hit rates, first pass hit rates on stack up and input, or input and stack up. And then the other one, also always around in every release, is our continued effort to try and process faster without any compromises for the quality of the result, of course. The last two ones are something for the admins amongst us. This version ships with the new version of Tomcat, the version 9.085, as well as an update of ant.jar, which is something that we use in the context of ODB generation. But for all these items here, as I said, do check out the release notes. There is technical data there, there is background, and there is images. So I'm sure that you will find everything you need if you go and look there. Also part of every release is a number of code fixes. You will find links to the lists of items that you have reported and that our R&D people have addressed. So there too, it's something that you will find once the email for the release has come in. So as always, once it's going to be available, do make sure to download and install it at your earliest convenience so that you can start enjoy all these new things that we have been talking about. Okay. I think that's it from me for now. I thank you for watching this video. It has been a pleasure showing you around. Take care now. Bye-bye.